So, welcome to the lecture on automatic control system. In this lecture, we will discuss about block diagrams. So, in previous lecture, we saw that in the design process of a control system, when we follow the frequency approach, that is to represent a system through transfer functions, we use the block diagrams to represent the system or the individual components, because a system is made of components and each component can be represented through block diagrams, and therefore a block diagram is made as input, output and transfer function. So we can represent this block diagram as so this is the block, this is input, this is output and this is transfer function. And so this is we call the block diagram. So let's say here is some input Rs, this is the transfer function Gs and this is the output Cs. So S is here the complex frequency domain or Laplace coefficient. S is the Laplace variable. S is a complex variable. We will discuss more in the next lecture about this Laplace variable and Laplace transform and transfer function. But here we will discuss more about block diagrams, and we should understand that an input can be a function of time, but it can be converted to S domain using the Laplace transform, and the output can also be a function of time, and that could be also converted into the S domain using the Laplace transform. And Gs is a transfer function, and that is function of S. So this transfer function is the property of a system or a subsystem. So here we will, in this lecture, we will understand some operations of on the block diagram. Means if the block diagrams, because we know that in the design process we reduce to a single block diagram for a components block diagram. So how to reduce to a single block diagram if we have a components block diagram? And therefore there are certain operations that we should know and we must know. These things will be discussed. So a block diagram has some input, transfer function and output. So here we can write Cs equal to Rs into Gs. So here's output is, if you multiply input with transfer function of the block diagram, this is the output. Now we understand the summing junction, because we saw that summing junction we saw that summing junction, there are several inputs, several signals comes and they are algebraic operation is going on. Either these signals are added or subtracted. So what is the property of summing junction? So let's say we represent summing junction like a circle and a cross, and there is, suppose there is one signal R1S coming, and this is plus sign, so this is going to be added. Then there is another signal R2S, and this has also plus sign. Then there is some other signal R3S, and it has minus sign, so it is going to be subtracted. So subtraction of the R3 and addition of these. So what will be the output of this summing junction? What output will pass from this summing junction if these three signals are coming at this point? So this R1CS will be equal to R1S plus R2S and minus R3S. So we understand the operation of a summing junction, and so when there are multiple signals entering at this, we should know that what will be the output going on, because usually summing junctions are used before the controller. So the controller will get this part CS, that is has this relationship with the input signals. Now there is another operation, that is peak off point. So here is peak off point. So peak off point, there could be one signal coming, and it might be entering into multiple signals. So one signal is going to be divided into multiple signals, and so this RS will be the same here. This is also RS, this is RS, and this is RS. So whenever we have some another block, in that block the input will be the same RS. The signal from the peak off point is the same, how many branches it is going to be divided. So these are a few points. Now we will discuss some more familiar parts. They are if the blocks are in series and the blocks are in parallel. So the blocks in series are called the cascade form, and blocks in parallel are called the parallel form. So first we will discuss the cascade form. So let's discuss the cascade form. Or series form. So let's say if we have some input RS, there are blocks here, and there is certain output CS, and this block has a transfer function G1S, this has G2S, and this has G3S. Now we want to know if there are three blocks in series, what will be the CS, because we want to represent this system into one block, that is RS and CS. So what will be the equivalent transfer function, so that we can replace these 3 blocks by 1 block. We can reduce these blocks to a single block. Now, how we will know? So let's assume that if there is input, there is a system transfer function, there will be some output, and that output will be input to this system, and the output from this system will be input to the third system. And let's say this output is x1s and this output is x2s. So we apply this rule that if we have input Rs, transfer function Gs, so output Cs can be expressed as Rs into Gs. So here x1s can be written as Rs into G1s, and x2s can be written as x1s because input is x1s into G2s. And Cs can be written as x2s into G3s. Now, here Cs equal to x2s into G3s, and x2s is x1s into G2s into G3s, and x1s equal to Rs into, let's say this is Gs, Rs into G1s into G2s into G3s. So you see what we are doing. So here Cs is equal to Rs into Gs. So x2s we can write x1s into G2s. Now x1s we can write Rs into G1s from these equations. And so finally we are going to get Rs into G1s into G2s into G3s. Now if we, so this is equation 1, here Cs equal to Rs into Gs, and this is equation 2, Cs equal to Rs into G1s, G2s into G3s. Now if we compare the two equation 1 and 2, we can see that Gs equal to G1s into G2s into G3s. So means we can replace these 3 blocks by 1 block, and this block's transfer function will be multiplication of the individual blocks functions. So here a general conclusion we can draw is that if the blocks are in series, we can replace them through a single block, and the transfer function of that single block will be the multiplication of the individual blocks. So that is the equivalent transfer function. Here Gs is the equivalent transfer function. Now we come to the parallel form. That is the second form, parallel form. So now parallel form, let's have input Rs, and there is a peak off point So suppose we have these RS and there is the 3 blocks in parallel, and the blocks are going to be added here at the summation junction, and we are going to get the output from these 3 blocks. So we want to know that if we want to replace this block with a single block, and that has a transfer function GS, and this is CS, and this is RS. So what will be GS as a function of G1s, G2s and G3s? Now again we will apply the simple principle, this one that we applied in the case of cascade form. So you know that this is a pick-off point. So a pick-off point, here input is RS. So each of these branches will have the same input RS. So means here is RS input, here is RS input, here is RS input. And so here will be some output. Let's say x1s, x2s, x3s. Now we know that x1s equal to RS into G1s, because output is equal to input into the transfer function. Here x2s equal to RS into G2s, and x3s equal to RS into G3s. Now here CS, there is all plus. So summing junctions, so CS equal to summation of the 3 outputs. So summation of the 3 outputs, we have x1s plus x2s plus x3s. So we have RS into G1s plus RS into G2s plus RS into G3s. Now we can take RS outside and we can have G1s plus G2s plus G3s. So we can see here CS equal to RS into GS, and we compare this equation with this equation. So we get that GS equal to G1s plus G2s plus G3s. So we can see that in this case, when we have 3 in parallel block diagrams, and we are going to add these 3 block diagrams, and then we want the output of these block diagrams. It is the summation of the 3 block transfer function of the 3 block diagrams. So the equivalent transfer function is summation of the individual block diagram. Now remember that if in spite of plus, here is minus, 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 there will be minus, minus, and minus. Any of the, if one is here plus, then there will be plus. If minus, this will be minus. Now another most important form that we will discuss is the feedback form, because we know that feedback form is the most useful form for the closed loop system, and therefore in the automatic control system. So we will discuss the feedback form. So here this is the error or actuating signal. Yes, the transfer function of this G1s is the plant and controller transfer function. This is the feedback transfer function. Here, this is the input. Now we will try to replace this system as an equivalent system. Let's say GES, that is the equivalent transfer function. So now here we can use something like, what is ES? ES is error function, that is RS minus, it is plus summing junction RS minus HS into CS, because what will reach here will be CS is this point CS, so CS into HS will reach here, so CS into HS. So this is equation number 1. Now what is CS? So CS equal to ES, because this is the input to this block, so ES into GS. So this is equation number 2. Now we can replace this ES from this equation. So ES can be written as CS by GS. So CS by GS equal to RS minus CS into HS. So from here we take these terms, we separate because we want this, so we have to separate CS terms and RS terms. So CS by GS plus CS HS equal to RS. We can take out CS here. So CS equal to 1 by GS plus HS equal to RS. So this is 1 plus GS HS, 1 plus GS HS by GS RS. So this is CS. So now we can write that CS equal to RS into so here CS into this term equal to RS. So CS equal to RS into GS upon 1 plus GS HS. So if we compare this with here, because here CS equal to RS into GES, this equation for this transfer function. So we can see GES is this part. So GES equal to GS upon 1 plus GS HS. So this is the equivalent transfer function of the feedback closed loop system. So you can see that this system we can represent to an equivalent single block system having the transfer function GS upon 1 plus GSHS. Now if here we have taken this minus, if it is plus, then there will be a minus sign here. So GES equal to GS upon 1 minus GS HS. If in spite of minus sign here summing junction it is plus sign, this transfer function we will get. So now we can discuss some properties of block diagram. So what we see from this, that it is easier to make a block diagram for a physical system, and we can evaluate the contribution of each component to overall performance of the system. And by examining the block diagram, we can examine the parameters of that system, because block diagram consists the transfer function that consists the properties of the system. Once we have made the block diagram, it is, if I give you a block diagram, it is difficult to tell that what actually the physical systems looks like, because physical system is transferred to the block diagram as a parameter consisting the parameters of the system. It could be a similar block diagram can be achieved for a mechanical system or electrical system or some other system. So from just seeing the block diagram, we can't tell that what actually is the physical system. So block diagram takes the property of a system where the physical features are not important, but what is important is the properties of the system that govern the performance of that system. The last point is that we can make several block diagrams for the same system. It depends on that how much detail we are going to include in that block diagram. Whether we are going to include some parameters or we are going to leave that parameter. Whether we are going to consider that system as a first order or second order. So this will change the block diagram, the transfer function. So therefore, it is possible to make several block diagrams for the same system depending on our consideration of the characteristics of the system. So here we stop, and I thank you for your attention, and let's see in the next lecture. Thanks.